Right, on problem number 7, the manager at Starbucks is collecting data on the amount of coffee in tall iced coffee orders that her baristas are filling. She found that 10% of orders have more than 13 ounces of coffee, 60% have less than 10 ounces of coffee. Assuming the data is normally distributed, determine the mean and standard deviation. So 10% have over 13 ounces, 60% have under 10 ounces. When we're determining the z-score using our z-table, we need to make sure we're looking up the percentile. So in this case, 60 is the percentile because it represents the percent that's less than 10 ounces. In this case, however, 10% is over 13 ounces. That means 90% is under or less than 13 ounces. So 90% is what we're looking up. So in our z-table, 90th percentile, we want to look for what is closest to 0.9 in the inside of the table. So in this case, 0.8997 is as close as we can get to 90% with a z-score of 1.28. And when we set up the z-score formula, all we know is the data value is 13. We don't know the mean, we don't know the standard deviation. In this case, we want to find the decimal percentile that is closest to 60%. So up here, this would be closest. 0.25 is the z-score, which we know is for the 10 ounce. We don't know the mean or the standard deviation. So here we have a system of equations that we could solve if we can isolate one of these variables. So in this case, if we cross multiply, we get 1.28 sigma equals 13 minus x bar, which would make it pretty easy to isolate the x bar. So x equals 13 minus 1.28 sigma. If I take this and substitute it into here, this would be 0.25 equals 10 minus this expression divided by sigma. So we can now solve for the standard deviation. So this would be 0.25 sigma equals 10 minus 13 plus 1.28 sigma. And then 0.25 minus 1.28 is negative 1.03 sigma equals negative 3. So we want to do negative 3 divided by negative 1.03. The standard deviation is 2.9. So standard deviation of 2.9, if I go back to here and find the mean, it would be 13 minus 1.28 times the standard deviation, and you get 9.3 for the mean.